Hi there, today I want to talk about a very important chapter in Statistics 2 for A-Level Maths HSC. The chapter is Sampling and Estimations. And my discussion today would be specifically based on estimations. So when we talk about estimations, we need to understand that estimations are normally calculated from observations. And where do we get our observations? Okay, so it could be that, well, as is always the case in statistics, you may have, let's say, a population. Here's the population. Now, from this population, a portion of people, items, or maybe animals, all right, depending, is taken. So this is what we call a sample. And now here is our sample. And the sample is put under observations. So we study data, we observe them, and then we calculate estimates. And when we talk about estimates, we often refer to an unbiased estimates. Basically, estimates are unbiased. Estimates are unbiased. Okay, if the expectation of the sample and basically I'm talking about the sample mean is equal to the population mean. So that is when estimates are basically unbiased. Now, estimates can either be point estimates, okay, and these can be point estimates, which is basically one value, and we can also have or interval estimates. And when we talk about interval estimates, we basically refer to an interval. And we will look at examples that will actually clear off any confusions about these problems here. So let me just refer now to what we call point estimates. Now, we actually have what we call unbiased estimate of the population mean. So unbiased estimate of the population mean, and this is normally referred to as, it's denoted by this symbol U hat, basically read as mu hat. And also we can have an unbiased estimate of the population variance. Unbiased estimate of the population variance. And that is denoted by the sigma to the square with a hat on top of it. So basically, our sample mean, which is mu with a hat on top, all right, sample mean is where we refer to this as the x bar. Okay, so this is basically the sample mean. And where S is the sample, we can let S be the sample variance. Now if we, okay, if we let S equal the sample variance, and n the sample, and n equal the sample size. Okay, so what we basically can do is we can calculate an unbiased estimate of the variance, population variance, and that's going to be n over n minus 1 times s squared. Now, there's many ways of writing the formula, but one of the best ones, but before we move on to the formula itself, we can also talk about the unbiased estimate of the sample proportion. Okay, let the unbiased estimate of the sample proportion of success be p hat. So then p hat, which is the sample proportion, ps, the sample proportion, okay, is going to be equal proportion, okay, of success in the sample. We often come across examples like how many people like to wear glasses on the beach, all right, on a Saturday when the sun is shining. So we can have a proportion of, let's say, 9 out of 10 people would do so on a Saturday. So that's our proportion. And this is basically referred to as our proportion of success. And the proportion of failure would be 1 minus the proportion of success. You get the proportion of failure. However, now what we want to summarize is these, the mu hat, the standard deviation, unbiased estimate of the population mean, population variance, and also the proportion of success in the proportion of success in the sample are known as point estimates. Okay, I guess this is basically a very nice introduction to the chapter. But before we finish off, I would also like to give you my favorite one. When it comes to calculation of the unbiased estimate of the population variance, I basically use this formula, n over n minus 1, and inside I refer to 1 over n summation of x squared minus the mean, all of that to the square. Here we are. I guess for this introduction pretty much was said, and I'm sure you've been able to understand how we're going to go about and deal or handle situations when it comes to estimations. However, in my next video, we're going to be working a couple of examples to clear all these concepts, to look at them, how we can actually work questions and understand these more clearly so that we can use them in future to be able to solve exams questions. Take care.